Hey guys, we definitely miss you. So here is the next set of notes. If you're interested in taking a look at it, I'm going to try to show you what to do on these and see if you can follow along. You can use this video to help you when you're working on the practice on ALEKS. So this is the Unit 8 parabolas one, except now what we're going to find is the root of each of these. So a parabola or a root is where the graph crosses the x-axis and y is equal to 0. So these are pictures of the roots. So when something asks for the roots of the parabola, then these are the pictures of them. They're these points right here that hit right on the x-axis, okay? It's also called the solution of a function or the zeros of a function. All right, so the first example or the first topic that you're going to see in ALEKS is called solving by graphing for a parabola. So first thing you're going to do is you're going to graph the parabola with a vertex and 4 other points, and then you're going to find where the graph crosses the x-axis. So remember, when we've done graphing parabolas, we did it last time. We'll see how much of you remember this. Okay, to solve for the vertex or to find the vertex first, then we need to do x is equal to negative b over 2a, remember? So this one, a is the number that's out front of the x squared, b is the number that's out front of the x, and c is the number that is by itself. That's how an original parabola equation is set up. So x is equal to, since b is 8, it's negative 8 over 2 times, and a is 1, so that's just 2. So negative 8 divided by 2 is negative 4. So we found that the x of the vertex is negative 4, so remember, plug it in. So we're going to plug it back into the equation. So we're going to say, okay, x is negative 4 now. Let me give myself some room here. So since x is negative 4, then I'm going to plug it back in. I've got negative 4 squared plus 8 times negative 4 plus 12. Okay, so negative 4 squared is 16. And 8 times negative 4 is negative 32 plus 12. Okay, so just combine all of those. You've got 16 minus 32 plus 12 is equal to another negative 4. So that means our vertex is going to be at, so let me write that down up top here. Our vertex is going to be at negative 4, negative 4. Okay, so let's plot that. So we're going to go over to the left, 1, 2, 3, 4, and we're going to go down 1, 2, 3, 4, and that's the start of our parabola. That's the vertex of the parabola. Remember, when you're graphing parabolas, they still follow that same pattern, which is you go right and left 1 times a, whatever a is, and then you go up, you go up or down 4 times a. In this case, our a is 1, so we're just following the same pattern, and it is positive, so this is going to be up. It's going to be a going upward direction parabola. So from this vertex, we're going to go over 1, over to the right 1, and up 1, and plot a point. Then we're going to go left 1 and up 1 and plot a point. And then we're going to go right 2 and up 1, 2, 3, 4 and plot a point. And then we're going to go left 2 and plot 1, 2, 3, 4 up and plot a point. So there's all your points. So we're going to graph the parabola as best we can. Okay. And then what they want to know is what the roots are, what the solutions are. So remember, the solutions are the points that hit the x-axis. So your two solutions are, let me just scroll up so that I have some room to show you. Your two solutions are x equals negative 2, because that's where that is at, and negative 6. Those are your two solutions to the parabola equation, and that's how you solve it, by graphing. Okay, so that's one way to solve for the solutions of a parabola. Up for the remind, you can send me a remind message, or I'll even be checking Google Classroom as well. So let me know if you have questions, and hopefully I'll see you guys all soon. Okay. On the next set of notes and the next set of topics in ALEKS, you're going to solve or find the solution of the quadratic by factoring, okay? So the first thing you're going to do in each of these equations is you're going to take out any GCFs, so greatest common factors, and then you're going to set each factor equal to 0, and then solve for the variable. Okay, so we're going to follow those steps. So in the first one, there isn't anything that you can take out. In fact, they have already all been taken out. So we are literally skipping the first step. We've done the first step of taking out any GCFs. Now what we're going to do is we're going to do this next step, which is set each factor equal to 0. Okay, so we say y minus 1. Remember, these are factors, okay? There are 3 of them, okay? So first we're going to do y minus 1 is equal to 0. The first factor doesn't have y in it, so we don't need to worry about that one, okay? The second one is y minus 1. So if we set y minus 1 equal to 0 and we add 1 to both sides, then we get y is 1. There's one of our answers, okay? And then if we set the next one equal to 0, so let me divide it a little bit, we have negative y plus 5 is equal to 0, okay? The best way to solve this would be to move the y onto the other side because it's negative and I want it to be positive. So I'm going to add it. So if I do that, I have y equals 5. There are your 2 solutions to the equation, okay? So we didn't have to factor that one out or factor out a GCF because it was already done for us pretty much. Notice in the next example, we again have 1, 2, 3 factors, okay? So since we have 3 factors, our goal is to set each equal to 0 and solve. So you have negative 2x equals 0. And if I solve that, that's negative 2 times x. So the opposite of times is dividing. So if I divide out the negative 2, I get x equals 0. There's one solution. In the next equation, we have x minus 3 equals 0. If I add 3 to both sides, then I have x equals 3. There's a second solution. And in the last one, I have x plus 1 equals 0. And if I subtract 1 from both sides, I get x is equal to negative 1. There's your third solution, or root. Okay? If I scroll down here, in the next couple examples, we're going to have to take out that GCF and do that first step. Okay? So if I take out a GCF here, the number and letter that they have in common, take out a GCF. They both have a 5 in common and they both have an x in common, right? So we take out a 5x. When we do so, okay, what do we have left? If I take out a 5x out of the first one, I only have 1x left. Minus, if I take out a 5 out of 10, I have 2. And there is no other x left because I already took it out. So that is equal to 0. Now, as you can see, I have 2 factors. So the next step says set each piece equal to 0. So 5x equals 0. Divide by 5, x is 0. There's one solution, okay? And then you set the other one equal to 0. So we've got x minus 2 equals 0. Add 2, x is equal to 2. There's your other solution. Same thing with example number 4. Take out what you can. Take out the GCF first. So they share a 4. They also share a y. So I'm going to take out a 4y. And what do I have left? If I take out a 4y, I've got a y left in the front, plus, and I have 24 divided by 4 is 6, and that's all that's left, equal to 0. So again, 2 factors. 4y equals 0, divide by 4, y is equal to 0. There's one solution. Second setup, y plus 6 equals 0, minus 6, y is equal to negative 6. There's your second solution. Okay? Now there's one more way to this. Let me know if you have questions. I'm going to set up a Zoom, I believe, so that you can video chat with me if you have questions and I can try to answer them that way. Or you can send me an email, or if you solve for the roots, okay? Sometimes we have to factor first. So this is why we did an entire unit on factoring before we got to this unit, because you need to remember your factoring skills and use your factoring skills to factor out the answer, and then set each piece equal to 0 so that you can solve. So first, though, notice the first step. You have to make sure that you bring everything to one side to make the equation equal 0. In order to be able to solve this, whenever you're factoring, the equation has to be equal to 0. So notice the first two examples, example 5 and example 6, they are already equal to 0, so they're ready to go. Now you're going to do the factoring, okay? So what are two numbers that multiply to get you 9 and add or subtract to get you 6? I'll set up my equation here with the open parentheses. I'm going to put U up front because that's the letter that they use. And the two numbers that make 9 and 6 are 3 and 3. And since it's a minus plus setup, I'm going to put two minuses in there. And that is equal to 0. And what I'll do is I'll attach the cheat sheet for the factoring that I have you guys use in the classroom to this assignment so that you'll be able to use that. Piece equal to 0 now. I'm going to say, well, they're the same thing, right? So I'm going to say U minus 3 is equal to 0. Add 3, U is equal to 3. There's your one solution to this equation, okay? Now we're going to factor again in example number 6. So if I factor again, I'm thinking of 2 factors of 12 that get you 4. So when you add or subtract, so that would be 6 and 2. So open up your parentheses. X and X goes in the front. 6 and 2 goes in the back. And since it's a plus minus in your equation, then it's going to be plus the bigger minus the smaller. Okay? Equals 0. So again, set each piece equal to 0. So x plus 6 equals 0. Minus 6 minus 6, x is equal to negative 6. There's one solution. X minus 2 equals 0. Add 2, x is equal to 2. There's your second solution. The next two examples require a little bit more work on your part. Notice example 7 does have it equal to 0, but example 8 does not. So example 7, we're going to do the Berry method of factoring because it has a number out front. So ready? We say 4 times 3 is 12. We're thinking of factors of 12 that get you 13. 12 and 1, okay? And this is where you lie to set up your answer. So you say 4x, and since it's a plus plus, I'm going to use plus 12. 4x plus 1. Now, what can I take out of the first one? I can take out a 4. So I'm left with x plus 3 and 4x plus 1. There's our final factored form. So now your next step is to set each piece equal to 0. So you say x plus 3 equals 0. Minus 3, x is negative 3. There's one solution, okay? And then we say 4x plus 1 is equal to 0. This one's a little trickier. Minus 1. We've got 4x equals negative 1, and then we need to divide by 4. So if we divide both sides by 4, we are going to have a fraction answer, and that's okay. So our second solution is negative 1/4. Okay? So our two solutions are negative 3 and negative 1/4 for that one. And example 8 takes the most work, okay? Because in example 8, it's not equal to 0. Instead, it's equal to negative 30x right now. So in order to get it equal to 0, what we're going to do is we're going to move that negative 30x onto the other side. The opposite of negative, and whenever you're moving something, is adding. So we're going to add 30x to both sides, okay? And we're going to rewrite our equation so that's easier to solve. So we have 0 equals 9x squared plus 30x, because the x comes second in the equation in the quadratic, plus 25. Now, I don't know how many people are going to notice this, but notice that 9 is a perfect square. Perfect square. 25 is another perfect square. When your equation begins and ends with a perfect square, you can go straight to setting up your factored form, right? What number squared gets you 9? 3x. 3x. So I'm going to put 3x at the top of both. What number squared gets you 25? 5 and 5. And since it's both a plus symbol, then I'm going to have both pluses on the inside. And then it is done. If you were to FOIL to check, you would see that this would come out to be 30x in the middle. Okay, so that is done. So remember to find your final solution, and the final step to all of these is to set each piece equal to 0. Since they are the same thing, we only have to set one equal to 0. So this is only going to have one solution. I'm going to say one solution. Okay, and it is going to be a fraction. So first step, minus 5. Okay, 3x equals -5. Then second step, divide by 3. So if I divide by 3, my final answer is the fraction x equals -5/3. And done. Okay, so you see that all of these notes, that's the end of the notes, but all of these notes take a lot of work. Look at all the work that I just did on this page, okay? So take your time with the practice.